Okay, so these are the questions we are discussing, which has been asked in JEE Main, Shift 1, 9th of January 2019. This is the 11th question we are discussing, and let me remind you, these questions are memory-based questions. Okay, so these are not the questions which has been declared officially by JEE. No, that these are the question has been asked. These are the JEE memory-based question we have, which we are discussing. You see, the 11th question here is from the chapter of polymers, right? And when these two combines, when the free radical polymerization takes place, which is usually takes place in presence of some peroxides or lights, right? So what happens here? The hydrogen combines, okay, and comes out as HCl, right? But which chlorine will combine? That is what the question we have. Okay, so here you see, first of all, these, because of this carbonyl group here and the electronegativity difference, this bond is comparatively weaker than this bond, carbon chlorine bond here. So obviously this chlorine will get attached with the hydrogen over here, correct? So you see, according to the option also, you see one of the hydrogen combines with chlorine, forms HCl, and this carbon and this nitrogen will join. Okay, so we have NH2, CH2, CH2, CO, NH2, right? So you see the option, we have this double bond obviously will break because it also attached with the other group, correct? So this we have carbon CCl, so CCl, and this is attached with the carbon which contains carbonyl group, right? So we have this carbon attached with carbonyl group, and the chlorine which is here is taken up by this hydrogen, forms HCl and goes out, right? And this molecule we have from here to here, right? Now another thing, what we'll do into this one, we'll take the another molecule of this, and the reaction proceeds in the similar way, right? So by look at the option, you can easily see that the reaction which proceeds and the radical will and the polymer will get here is option A over here. It is easily observed from this. Correct? This one is not possible here. You see, it is, you don't have to draw the molecules here. Only the thing is HCl will go out. So this H and this Cl will go out, and the product will be this. This you see NH, but we don't have C double bond O present. Do we have C double bond here? No. It only forms when this hydrogen will take this chlorine over here, right? But that is again not possible, right? Because this kind of reaction or the nitrogen hydrogen bond that will break here is this one, nothing but this one, right? It is a free radical substitution reaction. The free radical forms at this nitrogen because of this carbonyl oxygen here, the carbonyl group that you have. The molecule or this molecule, that NH2 that is present this side, this will not form the free radical. Okay, this bond will dissociate, homolysis reaction takes place over here, and hence the answer will be option A. So you may get confused with A and B, 1 and 2, right? These options are not possible at all, so you can eliminate these two options easily. You may get confused into this one, but since it is a free radical substitution reaction, okay, since it is a free radical substitution reaction, so the product will be this because of this hydrogen and this chlorine will join. So hence the option A is the answer here, right? Option A. Question number 12. The weight of Na plus in the solution of Na2SO4 is given, right? 92 gram. Find the molality of Na plus. Okay, so what is the formula of molality we have? It is the number of moles of solute divided by the mass of solvent in kg, right? So now you see in the question, number of moles we can find out easily because mass of Na plus it is given 92 gram. We know the atomic mass of Na plus also. So number of moles will be what? 92 divided by 23. This is the number of moles of Na plus divided by mass of solvent, molarity of Na plus per kg of water. So water is a solvent over here, and the mass of solvent is given per kg. This is 1. So the molality will be what? 20, 92 by 23, which is nothing but 4. Option 2 is right. Next question is, which of the following alkaline earth metal nitrate does not have water of crystallization? Okay. Okay. So all these nitrates belongs to which group? All these elements from which the nitrate has been formed belongs to group 2, correct? So first of all, there are two things here you can see. Group 2, there is one fact that we have studied, that the stability of nitrate or the tendency to form nitrate of the group 2 elements decreases as we go down the group. So for the group 2 elements, the tendency to form nitrate decreases as we go down the group, correct? So we have, according to this logic, you see the question is the following alkaline earth metal nitrate does not have. Okay, the question is for water of crystallization, correct, correct. So this is not actually, useful here. Let it be. This fact, let it be. This is not useful. Okay, since we have to find out the water of crystallization. Okay, so it depends on the polarizing power. Water of crystallization, polarizing power. It depends on the polarizing power. Okay, as polarizing power Pp increases, water of crystallization increases. Mode will be the water of crystallization. Because in water of crystallization, the water molecule surrounds the ions, okay, from all sides. That's why it is the polarizing part, is affected by the polarizing part. Now the point is what, as we go down the group of this divalent cation, that is Be2 plus, Mg2 plus, and all this cation that we have. So as we go down the group, the size increases, and as the size of cation, as the size of cation increases, its polarizing power Pp decreases. So less polarizing power gives you less water of crystallization, and hence according to this you see BaNO3 whole twice will have minimum water of crystallization, or there is no water of crystallization for barium nitride. That is the answer we have here. Option 4 or D. Which of the following option is correct for the given curve? Okay, this question is belongs to surface chemistry. Surface chemistry. And when I was teaching this, I have discussed this graph. Okay, so the relation we have here, we know what is x by m. It is the mass that is absorbed at the surface, right? So x by m is the ratio of mass adsorbed at the surface of adsorbate. Okay, x by m is that ratio. Okay, and it is directly proportional to pressure P to the power 1 by n, 1 by n, right, where n is an integer, correct? So when I remove this proportionality sign, we'll have x by m is equals to k p to the power 1 by n, right? Since the graph is for log of x by m and log of p, so we can write it as log of x by m is equals to 1 by n log p plus log of k, correct? Now here you see, this is the graph we have. So what is this 1 by n? That is what the question is. We have to find out the 1 by n value only, n value only. So 1 by n is nothing but, we can write this equation. This equation actually is in the form of y is equals to m x plus. So 1 by n is nothing but the slope of the line given in the graph. So what is the slope of the line? That is y by x, and that will be equals to 2 by 4, which is nothing but 1 by 2, and hence the option 1 is correct. Question number 15. Which of the following ore contains iron and copper? Okay, this is also, memory based question. Malachite, Malachite. Malachite, the formula is, it is a carbonate of copper, CuCO3 dot CuOH whole twice. I have write down the formula of this. Next one we have azurite, and its formula is, it is the two molecules of CuCO3 dot again CuOH whole twice. Means it is surrounded by two molecules of copper carbonate. Copper pyrite, you already know. Copper pyrite, it is the easy one, CuFeS2. CuFeS2. And the next one we have is none of this, fine. So the question is what? Which of the following ore contains iron and copper? So you may didn't know, you may don't know these two, these two formulas, okay, because these are not the common. Copper pyrite, you all know probably, right? They are very common ore that we see. It is given in all different books, correct? So copper pyrite is CuFeS2, and this contains iron and copper. Hence, the answer is straightforward, option 3. Correct. Next question number 16 we'll see. 20 ml of 0.1 molar H2SO4 is added to this, calculate pH of the resultant solution. Right? So first of all, you see the reaction is what? We have H2SO4 plus OH. And this gives you what? NH4 whole twice SO4 plus 2 moles of H2O. And if you balance this, here also we have 2 moles of NH4OH. Right, this is the reaction. So how many millimoles of H2SO4 we have? That is 0.1 into number of millimoles of H2SO4, 0.1 into 20, which is 2 millimoles. Millimoles of NH4OH, 30 into 0.2 is equals to 6 millimoles, right? 6 millimoles of this we have. Now in this reaction, you see, since the ratio is not same, 1 is to 2, and number of millimoles is also not same. So 1 combines with 2, so 2 combines with 4, right? And this is the, if you apply the concept of limiting reagent, this is a limiting reagent we have, because the acid will get consumed completely in this reaction. And when the reaction completes, we have this base present, NH4OH, and the salt of this base, weak base with strong acid. So first of all, the another point you have to understand here, the first point what we have discussed, we'll have this salt and we'll have this base. What is the nature of this base? This is a weak base and this is a strong acid. So this salt is the salt of weak base plus strong acid. So when the solution contains a weak base and salt of weak base plus strong acid, then this mixture we call it as basic buffer, right? This is a basic buffer solution, and for that we know the POH value. The formula of POH is equals to PKB plus log of concentration of salt divided by concentration of base. PKB value is given in the question. It is 4.7. Okay. So we'll substitute this value 4.7 plus log of salt is what? How many moles of salt we'll get? What is the concentration of salt we have here? That is 2 moles of this, right? So log of salt, so it is 2 by okay, so what is the concentration of salt we have? The reaction is balanced 8 or 5 7. Season is 4 plus 2 6. Oh, okay, reaction is balanced. So 1 mole combines with 2. So 2 combines with 4. So out of 6, 4 reacts and 2 millimoles of this base will left. Right, and 1 gives 1, so 2 gives 2 millimoles of the salt will get. So 2 by 2 will get okay. So the answer here it will be what? The value of log 1 is 0, POH is 4.7. So H will be what? Is there any temperature thing it's not given, so we'll assume 14 only. So 14 minus 4.7, and you will approximately get 9 plus 4 is 13. So we are getting 9 plus 9.4 approximately we'll get according to the option I'm telling you. So option B is correct over here. Right? Option B is right. Next question, question number 17. Consider the MOT, comment on the stability of this. Okay, so according to MOT, we know from molecular orbital theory, we'll have the concept of bond order, right? And from this theory only, we'll come to know that the bond order can have fractional value also. Fractional value. And when it has the fractional value, we consider that as a half bond. Right? So if you compare stability here, so more bond order, more will be the stability. Will be the stability. Right? There are possibilities that for two molecules will have equal bond order. So when the equal bond order is there, in case of equal bond order, the molecule which has less number of electrons in anti-bonding molecular orbital will be more stable. Okay, so for all these molecules, you have to draw the molecular orbital diagram. Okay, that is energy order. Those bonding and anti-bonding molecular orbital will draw. And then we'll calculate the bond order. If it is more, then the stability will be more. If it is equal, then we'll see how many electrons are present in anti-bonding molecular orbital. Okay. So first option you see, we have Li2 plus. Li2 plus will have 5 electrons. Right? Li2 minus will have 7 electrons. Okay. So the order will be what? Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. This is enough for this two ions we have. So when we distribute the electron in all these orbital, sigma 1s will have 2, here will have 2, here will have only 1 because we have 5 electrons. This is for Li2 plus. So for Li2 plus, if you compare the bond order, that will be equals to number of electron in bonding molecular orbital. So this is 2 plus 1, 3 minus 2 divided by 2, so that is half. Similarly, bond order for Li2 minus, that will be what? 7. So 2, 4, 6 and 7, right? So 3 electrons will have in anti-bonding and 4 electrons will have in bonding by 2. This is again 1 by 2. So you see the number of the bond order for the two molecules will be same, but here the number of electrons in anti-bonding molecular orbital is 2, and here the electrons in anti-bonding molecular orbital is 3. 2 plus 1, 3. So that's why Li2 minus will be less stable than Li2 plus. Okay, so this is the option we have: Li2 plus stable, Li2 minus unstable. So that's how answer will be option 1. Okay, similarly you can calculate this for other ions. If it is given, we have these two ions only. Li2 plus unstable, wrong. Li2 plus unstable, this is wrong. Li2 plus stable, this is wrong. So option 1 is correct. 17 no 1, option 1 is right. Question number 18. Which of the following is not correct about Henry's law? On increasing temperature, the KH increases. Right? On increasing temperature, value of KH increases. Right? It's correct. The value of KH increases, solubility of gas increases. Okay. So, the formula we have here, that is the partial pressure of the gas. Suppose P of any gas we have, it is directly proportional to its mole fraction, KH into X. Mole fraction that has been dissolved. So the value of KH increases, right? Value of KH increases, the solubility of the gas increases. Not possible, because we know this is the dissolution of gas is an, we can discuss about exothermic and endothermic nature of this also. If value of KH increases, that is possible when the temperature will increase, right? And when the temperature will increase, the dissolution of gas will be less into the water. Okay, so this we can also discuss over here, that hot water, if you drink hot water, you will feel like there is no taste. It's very, uh, the taste is very flat over there, correct? Or you can take the example of sea water also. The very all the aquatic animals used to live deeper into the sea, not at the surface of water. The reason behind this is what, the surface water is comparatively warmer than the water in the deep level that you have. So on the surface water at the surface, right, it is warmer because of sunlight, right? The surface water, since it has comparatively high temperature, so the dissolution of oxygen, the dissolved oxygen contained into the surface of the water, right, that is comparatively lesser. So what we can say, the oxygen contained or the dissolved oxygen contained at the surface of the water in the sea is lesser than to that of in the deeper, like to that of the what dissolved oxygen contained in the uh, deeper water or in the bottom of the sea, you can say, correct? So that is how we can conclude that the if the temperature of the solution increases, the amount of gas dissolved into the water decreases, correct? So the value of KH increases when temperature increases, correct? And when the temperature increases, the solubility of the gas will be less, okay? And hence the option 2 is wrong, okay? So correct one is option 2. See, the example I have taken now, you can easily compare from that. For option 1 and 2 are contradicting each other. Suppose 1 is correct, if you assume, which is actually correct because KH increases as temperature increases. I have discussed this in the class, right? Now you see, suppose option 1 is correct here, right? So option 1 is what, temperature increases, KH value increases. So when temperature increases, KH value increases. That is what the here we have. When value of KH increases, that is only possible when temperature increases. So it means in this option also, the temperature is increasing, so the solubility of gas should be less, right? It should decrease. But the option says as KH value increases, solubility of gas also increases, and hence this option is wrong. Hence the correct option is option 2. The value of KH, obviously it is different at the same temperature for two different gases, okay? So option 2 is right here. Question number 19. Zero point zero 0.05 Faraday charge is passed through a lead storage battery in the anodic reaction. What is the amount of PbS precipitate? Correct. Okay, this is question number 24. Okay, if you have the same paper, it should be question number 24. By mistake, I have taken question number 24 here. So you see, we'll solve this one only. Okay. So reaction here, it is what? PbSO4 we have. Correct. So the lead solid combines with SO4 2 minus and forms what? PbSO4, and 2 electron goes out. Okay. So the question is 0.05 Faraday charge we are taking, right? Now the molar mass of PbSO4, it is given in the question, that is 303 gram. Correct. Now since 2 electrons are releasing in this reaction, so what we can say, if you apply the concept of this Faraday's law, 2 Faraday charge, if this mass has to deposit, right, for the deposition of for the deposition of 303 gram. Why 303 gram we are taking? Because it is the molar mass of PbSO4. 303 gram of PbSO4, we need 2 Faraday of charge, because 2 electrons are going out. Okay, so 2 Faraday, the mass deposit is 303. So for 0.05, it will be 303 divided by 2 into 0.05. So when you solve this, you'll get 303 divided by 40, right? So 303 divided by 40, it will be more than 75, right? 40. So 303 by 4 is more than 75 by 10, so 7.6 around. Option 3 is correct, I think. Okay, so when you solve this, you'll get 7.6 gram approximately will deposit. Option 3 is right. Okay, very basic question, very basic application of Faraday's law. Whatever the values, whatever the charge is going out, equal Faraday will required for the deposition of the molar mass of that particular substance, whatever you have. Okay, so option 3 is right. Question number 20, you see, which the following property in a group decreases down the group and increases down the group respectively? Very simple one. I think electronegativity decreases down the group and atomic radius increases. So option 1 is correct. We know fluorine, chlorine, bromine, iodine. Fluorine is the most electronegative element, right? And atomic radius of iodine is more than to that of all other elements in the same group. So down the group, atomic radius increases, electronegativity decreases. So decreases down the group is electronegativity, increases down the group is atomic size or atomic radius. Option 1 is correct. So these are the another 10 questions from 11 to 20 that we have discussed. The last 10 we will also discuss very soon. Thank you.